Hi childrens, dear childrens, in the previous session we solved some problems based on the cross product of two vectors. Now in the session we will solve some more problems based on the cross product of two vectors. Here we have find the area of the parallelogram whose adjacent sides are represented by the vectors 3i plus j plus 4k and I minus j plus k. So we need to find the area of the parallelogram when adjacent sides are given. We know that we have the area of a parallelogram is equals to magnitude of a bar cross b bar. So here we need to find the cross product of two vectors, then its magnitude, which gives the area of a parallelogram. So now write the given vectors as a bar and b bar. So that is, write the first vector as a bar. So a bar is equal to, we have 3i plus j plus 4k and b bar is equals to I minus j plus k. Now find a bar cross b bar. Therefore a bar cross b bar, that is cross product of two vectors, is equals to, we have determinant of I j k. Write the scalar components of the vector a. So that is, we have 3, 1, 4. Again write the scalar components of vector b, which are 1, minus 1, 1. Now expansion of 3 by 3 determinant, expanding through first row, that is equals to, we have I into determinant of deleting this entire row and entire column, we have 1, 4, minus 1, 1. Again we have sign minus j into determinant of delete this entire column and row, we have 3, 4, 1, 1. Again plus k into determinant of deleting entire row and column, we have 3, 1. So 3, 1, 1, minus 1. Expansion, that is equal to, we have 1 into 1, that is product of principal diagonals minus the product of non-principal diagonals. 1 into 1, we have 1 minus 1 into 4, we have minus 4, minus of minus plus 4 of I. Again minus 3 into 1, 3, minus 1 into 4, 4 of j. Again plus 3 into minus 1, minus 3, minus 1 into 1, we have minus 1 of k. Again simplification, that is equal to 1 plus 4, we have 5i, 3 minus 1, 3 minus 4, we have minus 1, minus of minus plus 1 j, minus 3, minus 1, we have minus 4k, minus 4k. Now apply magnitude for a bar cross b bar, that is magnitude of a bar cross b bar is equal to square root of, we have 5 square, that is 25, plus 1 square, we have 1, plus minus 4 whole square, we have 16. Again that is equal to square root of 25 plus 1, 26, 26 plus 16, we have 42. Therefore area of a triangle, area of a parallelogram, area of parallelogram is equals to magnitude of a bar cross b bar. Again that is equals to, we have that is root 42 square units. So this is the area of a parallelogram. Next, find the area of the parallelogram whose adjacent sides are represented by the vectors a bar is equal to I plus 2j plus 3k and b bar is equal to 3i minus 2j plus 4k. So we need to find cross product of two vectors. Therefore a bar cross b bar is equal to determinant of I j k. Write the scalar component of vector a, that is we have 1 2 3. Writing the scalar component of vector b, we have 3 minus 2 1. Now expansion of determinant, that is I into determinant of leaving entire row and column, we have 2 3 minus 2 1. Again minus j into determinant of, so 1 3 3 1. Again plus k into determinant of, we have 1 2 3 minus 2 minus 2. Simplification, that is equals to 1 into 2, we have 2 minus 2 into 3 minus 6 minus of minus plus 6 of I. Again minus of 1 into 1 1 minus 3 into 3, we have 9 of j. Again plus of 1 into minus 2 minus 2 minus 3 into 2, we have 6 into k. Simplification, that is equals to 2 plus 6, we have 8i. Again 1 minus 9 we have minus 8 minus plus 8j. Again minus 2 minus 6 minus 8 minus 8k. Therefore magnitude of a bar cross b bar is equal to square root of 8 square 64 plus 8 square 64 plus minus 8 whole square, we have 64. Okay, again that is equal to root 64 plus 64 plus, we have root 192, root 192. Therefore area of parallelogram is equals to, we have formula, that is magnitude of a bar cross b bar. Again that is equal to, what is this value? We have root 192. Therefore root 192 square units. Next, find the position vector of a point which divides the line segment joining 2 points A and B internally in the ratio m is to n. We have to find the position vector of point. Position vector of a point. Here let AB be the line segment. So that is A, B. Let O be the fixed point. So let O be the fixed point. Again let A bar and B bar be the position vectors of point A and B respectively with respect to fixed point O. With respect to fixed point O, that is let A bar and B bar be the position vectors of point A, point B respectively with respect to fixed point O. Then we have OA bar is equal to A bar and OB bar is equal to B bar. Next, let P be any point, let P be any point which divides the line segment in the ratio m is to n internally and whose position vector is R bar, whose position vector is R bar. So that is let P be any point, P be any point on AB line segment AB, which divides the line segment AB in the ratio m is to n, m is to n, and whose position vector is what? R bar. That is OP bar is equals to R bar. OP bar is equals to R bar. Again here by the definition, we have AP bar divided by PB bar is equal to m by n. That is AP bar by PB bar is equal to m by n. So that is AP bar divided by PB bar is equal to m by n. So that is again cross multiplication, n into AP bar is equal to m into PB bar. Let this equation be 1. So now, so AP bar is equal to expressing this AP bar in terms of its position vectors. We have OP bar minus OA bar. Again that is equals to, what is OP bar? We have R bar minus, what is OA bar? We have A bar. So that is A bar. Similarly we have PB bar. So that is PB bar is equal to OB bar minus OP bar. Again what is OB bar? We have R bar. We have B bar minus, what is OP bar? We have R bar. Okay, now substituting AP bar and PB bar in equation number 1. Therefore 1 implies, so write the n as it is, n of AP bar we have R bar minus A bar is equal to, we have m, that is m int of, we have PB bar, that is B bar minus R bar, B bar minus R bar. Again simplification, n into R bar, that is n into R bar minus n into A bar, multiply the scalar to each vector, is equal to m into B bar minus m into R bar. So now bring m R bar to LHS and n A bar to RHS. So bring this to LHS and bring this to RHS. Therefore try to make all the terms as positive. Okay, therefore n into R bar, so minus m into R bar becomes plus m into R bar. Again that is equal to m into B bar minus n A bar becomes plus n into A bar. Again taking R bar common, that is m plus n of R bar is equals to m into B bar plus n into A bar. Therefore R bar is equals to m into B bar plus n into A bar divided by m plus n, which is the position vector of a point which divides the line segment in the ratio m is to n internally. Similarly, if it is externally, then we have R bar is equals to m into B bar minus n into A bar divided by m minus n. So you see, this is the position vector of a point which divides the line segment AB externally in the ratio m is to n. Again children, let hope is a fixed point. Let A bar and B bar be the position vector of point A and B. respectively with respect to fixed point O. Then OA bar is equal to A bar and OB bar is equal to B bar. Again, let P be any point on the line segment which divides the line in the ratio m is to n and whose position vector is r bar, that is OP bar is equal to r bar. So by definition we have AP bar divided by PB bar is equal to m by n. Now cross multiplication, that is n into AP bar is equal to m into PB bar. Express AP bar and PB bar in terms of its position vectors. Okay. Now simplification, substituting the values of AP bar and PB bar. Simplification. Okay. The bar is equal to m into B bar plus n into A bar divided by m plus n. So this is the position vector of a point which divides the line segment internally in the ratio m is to n, and this is the position vector of point which divides the line segment externally in the ratio m is to n. Usually this is also called as section formula. Section formula. Position vector of a point which divides the line segment P and Q whose vectors are 2A bar plus B bar and A bar minus 3B bar internally in the ratio 1 is to 2. Here has given A bar. So A bar is equal to we have 2A bar plus B bar and B bar is equal to we have A bar minus 3B bar 3B bar and m is equal to we have m is to n, m is equal to 1 and n is equal to 2. So m is equals to 1 and comma n is equals to we have 2. So we have formula. The position vector of point which divides the line segment internally in the ratio m is to 1 is given by, that is r bar is equals to m into B bar plus n into A bar divided by m plus n, Here again that is equal to, we have value of m, that is 1 of B bar. What is B bar? That is A bar minus 3B bar plus n of A bar. We have that is 2A bar plus B bar all divided by, we have, what is the value of n? That is 2. So that is 1 plus 2, m plus n, 1 plus 2. Again simplification, that is equal to we have A bar minus 3B bar plus 2 into 2 we have 4A bar plus 2 into 1 we have 2B bar all divided by 1 plus 2 we have 3. Again that is equal to A bar plus 4A bar we have 5A bar. So minus 3B bar plus 2B bar we have minus B bar divided by 3. Okay. So this is the position vector of point which divides the line segment. So joining 2 points, that is A bar 2A bar plus B bar and A bar minus 3B bar in the ratio 1 is to 2. Dear children, this ends the vector algebra chapter. Thank you very much.